Hello, what you're going to be watching today is the third video in a series of three videos we did as part of introducing our book, Effective Platform Engineering from Manning Publications. In the first two videos, we covered two critical topics. The first topic I covered was Introduction to Platform Engineering and why you should care about this topic. In the second video, I covered the concepts of technical product management and dive deep into using that as the backbone of your overall engineering platform journey. Please watch those videos before you watch Bryan's excellent video coming up following this message. Bryan will be talking about an idea called compliance at the point of change. Before we go further, let me introduce Bryan. Bryan Oliver is a principal consultant in the platform engineering team at ThoughtWorks, where he specializes in designing and building complex distributed systems. With a career spanning mobile and backend development, he has led autonomous teams and contributed to the evolution of cloud native patterns. Bryan is the author of not just this book, Effective Platform Engineering, but another book called Designing Cloud Native Delivery Systems. An active member of the Kubernetes SIG network and the CNCF Platforms Working Group, Bryan frequently speaks at international conferences such as KubeCon, CDCon, and CodeCamp. His work includes developing global multi-cloud engineering platforms for major clients like Ritchie Brothers. Outside of his professional endeavors, Bryan enjoys ice hockey, trail running, and he's striving to reach champion rank in the Rocket League. So over to you, Bryan.
Hello there. As you know, compliance and security are some of the number one things you need to do in platform, as well as just general infrastructure and development. I'm Bryan Oliver, and today we're going to be talking about a concept called compliance at the point of change. This is from our book, Effective Platform Engineering, which I am one of 4 co-authors. To kick this off, we're going to tell maybe a little bit of a story here at the beginning. This helps kind of understand the concept a little more and why it's so important. So in 1979, there were 2 brothers, Stuart and Hubert Dreyfus. They did a study on how individuals acquire mastery and become experts in their skills. In this study, they looked at the emergency response procedures of pilots, compared those response patterns of expert pilots to the skills of more novice pilots. In this study, the expert and the instructor level pilots were asked to create a systematic series of rules and procedures to use by the novice pilots. This was intended to be a representation of their best practices. The intent was successful. The novices were able to follow those experienced pilots' best practices and had some noticeable improvements in their capabilities. In engineering, this could maybe be compared to how an expert level programmer might write a book or a series describing the gotchas of a language, maybe like 100 mistakes in Go and how to avoid them, great book, or JavaScript, the good parts. These resources can be used directly for noticeable improvements for people new to the concept. However, in the same study, the experts and instructors were then told to kind of follow their own rules, and this significantly reduced their performance, actually. Why do you think that happened? It's because the true experts have intuition and they use it to make decisions. This intuition is not able to be written down or codified into a series of steps. It's kind of like asking a chef to write down a recipe that they just came up with. They usually just respond like a little of this, a little of that. They just know what to do. But if you tried to explain it to them, they'd probably struggle a little bit. If they tried to explain it to you, they'd probably struggle a little bit. Ultimately, out of this study came a system that's in use today. It's called the 5 stages of mastery, or 5 stages of expertise. The field of nursing, for example, uses this model to some degree. It describes how individuals progress through levels of mastery in that field. To kind of give you another reference point, in Andy Hunt's book, Pragmatic Thinking and Learning, he says, a misguided sense of political correctness dictates that we treat all developers the same, regardless of ability. This does a disservice both to novices and experts and ignores the reality that there is anywhere from a 20-to-1 to 40-to-1 difference in productivity among developers. What Andy's referring to here is that applying the same set of rules to both novices and experts is a heavily misguided approach to software development. It will destroy your ability to cultivate and utilize experts effectively. So going back to Dreyfus for just a minute, let's consider the results of the experiment. What they found was that the experts did not need or want to use a step-by-step recipe for emergency response. Instead, they utilized their intuition to make decisions. And when they were allowed to, they were drastically more performant when not forced to follow the procedure. The reason they were found to not use any, the reason they were found to not use any detectable scanning pattern, because they already had a feeling for what the correct next step would be in any given context. They just kind of had like a guttural feeling about it. Have any of you ever worked with like that person, the Phoenix Project character that just knows everything about your systems? When you pull that person in, they seem to almost know what's wrong before you've even finished describing the problem to them. This is extremely similar to the pilot scenario. If you were to force the expert sysadmin to follow a script, it would almost always be remarkably slower for them to fix the problem in hand than if you'd allowed them to attack it as if they'd see fit, as they see fit. Moreover, 9 out of 10 times you probably called someone that skilled because the script doesn't apply or the runbook doesn't work. Meeting the intuition of the expert is the only thing that we can use to solve the problem at this point in time. How many of you maybe read The Software Craftsman by Sanjay Mancuso? If so, you might be familiar with some of this. In the second chapter, he talks about Agile in depth, and he explains that Agile without technical excellence is just process, giving us many of the same benefits as well as cons as Waterfall did pre-Agile. Many companies adopting Agile even today will hire Agile coaches and Agile consulting firms who only focus on the process of Agile development. And those individuals and organizations fail to place an equal emphasis on the technical excellence. If we consider this quote in the context of our talk today, and we consider the findings of the Dreyfus case, we now understand just how important it is to have a good process in place, especially for your senior and experienced engineers. We saw that experienced pilots who were told to follow a checklist in the emergency situations performed poorly as opposed to using their intuition and experience. And we know from the software craftsman movement that you can have plenty of skilled and experienced engineers, but still grind your forward momentum to a halt when you have good engineers and a bad process, or the reverse, good process and no technical excellence. So through this video, we're going to show you an enabling pattern that kind of helps you to achieve technical excellence and relieves an enormous amount of friction for development teams, especially for those experienced engineers trying to deploy software to production. So let's talk a little bit about DevSecOps and compliance enforcement. In a regulatory environment, the average cost of non-compliance is $14.82 million. And this is very conservative. Depending on the company, these numbers can be quite a bit larger. When you compare this to a maybe less regulated environment, it's less than half of those costs. However, most of us today now work in some form of regulation because of the different laws and regulations that have entered into our industry. It's almost impossible to avoid. So it becomes a requirement that we as engineers become responsible for ensuring a compliant delivery of our software. There's a lot of different stakeholders and regulatory factors. So we've got things like OWASP and identity and infrastructure, approval, um, provenance, like all these kinds of different areas. It's quite a lot that we have to keep a hold of. So it can get quite complex. So let's talk maybe a little bit about like what DevSecOps is, and maybe break that down a little bit. to help you understand further. And the first thing you kind of need to understand, and you get this from the book as well, is that the evolution to platform engineering has come from these different areas. So DevOps and DevSecOps have been evolving into what we see as platform engineering today. Um, the tools, the processes, and even the way that we sort of approach these concepts have changed over the years. They've gotten better in some ways, worse in others. But there's definitely been a dramatic improvement in the processes and tools, especially when it comes to DevSecOps. We have these really advanced systems, some of them AI backed even, that help us do security at every single layer of the stack. Deployment testing is able to be much more flexible and customized by the developer. So this is an important evolution that we can use. Some of the building blocks that we use in a sort of successful DevSecOps implementation. There's tons of them. We won't talk about all of them right now, but there's things like runtime scanning, threat modeling, automation testing, SIEM, container scans. It's so easy now to build a container image for Kubernetes and detect that there's maybe a vulnerability inside of that with just a quick scan from one of 20 different open source tools that will scan it for you and let you know. These things are all at our disposal, ready to be automated. We talk a little bit as well about maybe a maturity model of using these different things, these different patterns that we see in DevSecOps. So some of the big ones like threat modeling, static code scanning, dependency management, automated testing. We see different orgs and customers and users at different levels of maturity in how they do these things. For example, at the number one at the top of the maturity tree in say dependency management, you have developers that are constantly fixing vulnerabilities as well as updating dependencies. They're involved in that practice as well as automating it for themselves so that it's continuously up to date, and we see little to no vulnerabilities or older dependencies in these teams because they've adopted that practice. One of the things that we tend to notice at the sort of higher levels of the maturity model is that as teams start to automate and get better with these different trees of DevSecOps, policy as code becomes extremely important because it is used to automate a lot of those different areas that we talked about. Enforcement of things like signed commits, of actually running container scanning, of doing DAST, of scanning your infrastructure as code. All of these things can be done with policy as code. So we notice that as teams become more and more mature in DevSecOps, they tend to so adopt policy as code and sort of build an engine of sorts around it. So when we jump into sort of the why and how we sort of balance these different things, one of the things we always have to consider as we jump into DevSecOps and compliance and all this is there's sort of three competing areas. We're balancing cost, time to value, and quality. You'll find in most organizations that they focus on two of the three of these things because it's very hard to focus on all three. So we're either going to sacrifice time, quality, or cost at some point, and you have to weigh what the outcomes of those decisions are going to be every time you make them. So with that, it's it's kind of good to understand what the normal state of governance is going to look like. And this sort of emerges from making those decisions we talked about from the three. So what we often see is either there's quite a bit of governance in the pipeline itself. So, like, you'll see commit, SAST, CVE, quality, maybe provenance, etc. And they're all different little like stop points in the pipeline itself. Or in the reverse is we have all of these tools sort of available and they're just there, and they're not always highly used. There's no checks, there's no accountability for those.
Hey folks, if you're enjoying this content, don't forget to check out our book published by Manning. It goes way beyond what we are covering here, with deep dives into real world patterns, hands on exercises, and even case studies from industry leaders. For instance, you'll learn how to build scalable microservices with zero downtime deployments, and how to optimize developer experience using internal platform principles. The link is in the description, along with an exclusive discount code. Grab your copy today and level up your skills.
Um, so with those two, we kind of get to the question of, like if we go back for a moment, you look at the first one, which is there's no accountability, and in the second one, there's tons of accountability, but lots of friction. How do we So the question we begin to want to ask ourselves, and again, going back to those three of comparing cost to time to value to quality, is how do we break away the doing of compliance work from the evidence of the proving of it? Meaning, like, how do we, if we go back here for again, how do we get the flexibility of the top option while having the accountability of the bottom option? And this is where we get into a concept we call governance at the point of change. It leverages what we talked about a moment ago, policy as code, to sort of get into this pattern. And the way it works at a very high level is those governance checks that we saw in the previous one, that are sort of sprinkled throughout the pipeline. Those are going to move to the end of the pipeline within the deployment stages. So what you'll see instead is, as we move through those deployment steps to the test environment, to the production environment, those accountability checks, those governance checks are occurring at that point instead of in the developer's pipeline and the development pipeline. We call these gatekeepers. Um, and the way they work is effectively the accountability checks, the stopping, like the stop go, is at the gatekeeper level instead of in the pipeline level. Meaning you still have all that policy as code that the developer can use in their pipeline as they wish, free the gatekeeper section. However, it's not doing any enforcement. So it's the flexibility of that first option that we talked about, where they have all those tools in the policy as code engine at their disposal, but they are not being forced to follow a rigorous process. They can create their own process to get up to the gatekeeper stage. Um, to understand this a little bit better, we may have, say, a security team that manages the scanning of CVEs for teams by creating an automated package that does it for them. How the teams use this package is entirely up to them. They can put it into the pipeline at the beginning or at the end, and that's their choice. They just consume the package. The enforcement of the use of this package only occurs once deployment happens to the gatekeeper that we talked about at the beginning of, or at the end of the pipeline, the deployment phase, effectively. Yeah. Another use that we commonly seen with this pattern is maybe like an approval controller. So if you have a highly regulated environment where maybe the engineer is not the only one that can sign off on going to production, maybe you have a Jira approval or a Jira sign off that says um, this is good to go to production. Maybe it's a product owner, for example. We might have a gatekeeper at the deployment API that says, has this been checked off by said person, yes or no? This moves that approval step away from the developer pipeline, so there isn't like an overburdening process in their development cycle. Like they can still maybe get to dev or test without having to have all these extra approvals. It can just be at that production step in the deployment itself. So it's actually quite powerful. So some success factors that need to be considered when adopting this pattern. Um, and then after this, we'll talk a little bit more in depth about the pattern itself and maybe some technical details. Is adopting an engineering platform strategy like we define in the book is really key to using this pattern successfully. Um, so if you can kind of see here, like when you define an engineering platform that maybe deploys to multiple targets, like let's say your users, your developers have, use EKS, they use ECS Fargate, and they also deploy to Lambdas. The cool part about this pattern is if we build our engineering platform correctly and adopt this pattern, we can use compliance at the point of change for all three because the admission controller API or that deployment checks API, the thing that's using policy as code to make them accountable, is simply an API that the deployment is running through to be scheduled to the proper target. So in the case of, say, Lambda, you might have just a deployment pipeline that then calls out to a Lambda deployment API. And that API is what's saying, did you run through all of your accountability checks before deploying? Another thing to understand is engineering platforms, especially with this pattern, they really simplify um, software delivery as well. So as we sort of adopt all of these different governance and compliance checks, say SaaS and CV and quality and runtime, like all of these things become easier because we're also creating sort of automated packages as well as packaged up policy as code bundles that make it really easy to consume all of these patterns. So like as more and more teams join your engineering platform, they're able to benefit from all of these really quickly because it's been made so easy for them to adopt these things instead of being forced to consume this massively regulated pipeline with tons of stopping points. They build it themselves to get to the point where they're passing the deployment check at the end. So they also understand it every step of the way instead of just being handed this big monster. Um, Another thing to consider is this is sort of an enabling pattern for governance and compliance, meaning kind of like we were talking about, where it's making it easier for those teams to join in and consume those patterns that we were talking about. The best practices we saw on the earlier slides on DevSecOps then become pretty much standard across your organization. Um, so like static and dynamic code analysis and code provenance, these are no longer like aspirational goals like we see in many organizations. They now become just things that become common for any development team. The last thing is to understand it maybe a little bit more thoroughly, you can kind of think of these accountability checks as like guardrails. So meaning you, like say you have a piece of code that you're getting to production. You now define the process for how it gets there as a developer. But when you get to the end, to the production stage, there's a guardrail that is effectively shaping like how you deliver that software to the production environment. Meaning, you're handed all these different tools and packages that help you do things like security and compliance checks. And when you get to the end, because you've kind of followed those guardrails, instead of them being stoplights, they're just, kind of like guidelines. When you get there, that delivery of your software is much smoother. So to think about it from a maybe slightly different perspective, we could talk about different like hypotheses. For example, the number and complexity of ticket requests resulting in slowdowns of software delivery. Um, when we start to adopt governance at the point of change, we'll start to see a reduction in ticket requests for, say, CVE exceptions, because we've begun to adopt a lower friction process for remediating those CVEs. Meaning, to give you sort of a concrete example, we've seen teams that, they might have 5 or 6 CVEs while they're working on a feature, but they're just deploying it into dev, into test. And the CVE check, that's, the compliance at the point of change, CVE check, is maybe at the production stage, or at the production admission controller. And they're able to kind of defer going through all those until they've worked through their feature, and then they might go update the dependencies at the end instead of interrupting their entire flow because one came up and then tomorrow 2 more came up, and like they're constantly being interrupted by those stopping points. Instead, they can just kind of check through all of them when they're ready to go to production with that feature. And this drastically reduces a lot of those tickets that come through for, say, exception requests on critical CVEs, because what we've seen a lot is when these things come up and they're constantly interrupting flow, they're taking time away from those teams, which means they deliver late. When you deliver late and you have critical CVEs, often the leadership of the company wants to get those features out quickly and will write off critical vulnerabilities to get the business value out faster. So we see a reduction in this occurring when adopting this pattern. So let's now get into the technical details a bit of the pattern. Obviously, in the book, you can go much, much further, but this should give you a pretty solid overview. Um, so to kind of like recap a little bit, the decision you're making here, adopt this pattern, is you are handing ownership of the pipeline to the developer outright. And we see this as one of the most friction reducing architectural patterns available today. To kind of recap on the everyday context, some of the things that we're trying to accomplish: provenance, standards, CVEs and vulnerabilities, quality configuration, and we'll go through some of these to kind of give you better examples of how they work. And in the previous world before this pattern, you'll see these different areas sprinkled kind of throughout the pipeline, like we talked about, where maybe the CVE isn't early on, like we're interrupting, as we were talking about. We might have OWASP later on in the process, attestation. These are all sprinkled throughout as little stopping points. And what we end up with is this, where there are just tons of stopping points in our development process. And this is what makes the delivery of software run behind, run late, and lag. If we return to the discussions from Dreyfus earlier, we should also consider the effects of applying strict procedures and rules in our teams with seniors and leads on them. We're effectively here forcing them to use a checklist by making them use this pipeline you see here. So what would happen if we gave those teams autonomy to self-regulate this pipeline and change how it works? And to do that, what we need to understand is how this concept works at a tactical level. So we're going to use the Kubernetes admission controller as an example. It is not the only way to do this, but it is a technical example that's very solid in terms of how to adopt this pattern. So looking at it as an example, we can use this as the enforcement for our point of change. So consider like a Kubernetes deployment in which certain criteria for that deployment are required. You might, before learning about compliance at the point of change, validate or block that deployment in the pipeline. Now, with compliance at the point of change and the ability to implement an enforcement point at the boundary of a cluster, you can move that validation and blocking to the cluster itself through the Kubernetes API. Why this is important, consider it from an auditor perspective. The goal of compliance at the point of change is the separation between the doing of compliance and the verification, right? Well, the K8's admission controller allows us to accomplish exactly that because it gives developers control of that pipeline doing the compliance and security work. Um, and governance or security teams control over the admission controller in the Kubernetes API. Um, Traditional compliance says combine the two and vest that as a separate team as a proxy for verification of compliance. But traditional compliance doesn't actually do verification of compliance typically, other than that like one-off or twice yearly audit that everybody stresses about that may or may not catch non-compliant states depending on the approach of that team or that auditor. Whereas this pattern is applicable across all tech and platforms, the requirement being some form of admission controller or control plane API. The important defining characteristic is that something is intercepting and validates the evidence and either allows or blocks the action based on the evidence. And the thing doing the interception is this policy is under the domain of governance and security. Um, so you can kind of like see it here in the diagram, like we're submitting like a deployment request to Kubernetes, and there's this sort of validating admission controller sort of side step that occurs that goes through and looks at the metadata of your deployment request, like have you done security scanning and provenance and all these other steps. And there are various ways for the development team to prove to that bit of policy code that yes, I've done all these things and here's the different links to them so that the controller can go verify them directly. There are other places you can do this pattern though, but it's not limited to Kubernetes admission controller. AWS Control Tower, Terraform Cloud plus Sentinel, Open Policy Agent, many others. So to maybe jump into some different examples,
Quick reminder, if this video is helping you, hit that like button and share it with your friends or colleagues. Maybe someone's struggling with that exact problem that we are solving right now, like implementing CI/CD pipelines that actually reduce toil or building secure by default cloud infrastructure. Your share might be the key to helping them solve their problems. It also helps support the channel so we can keep making more in-depth practical videos like this one.
let's look at known vulnerabilities. The organization's policy in order to be compliant and secure is not to ship code with vulnerabilities, like let's say an example organization. So we agree that the way we do the work is through a third-party product such as, say, Sneak. We provide developers access to the tool. We provide pipeline code, maybe an orb from Circle CI that makes it easy to add a feedback step into the pipeline. And in fact, the default pipeline that comes through the language starter kit will already have this logic built in. Developers have access to the API that will independently analyze the code, they get feedback and they can respond, and they can have ownership of their pipeline. Any changes they need or want to make are unblocked. Assurance of compliance doesn't depend upon simple assigned responsibility within separation of duties here. Instead, with each attempted change of running code, the system will verify compliance CVE scans and state. So, i.e., in each deployment, the system will verify these scans. In this, we use a tool called Gatekeeper that lets us define policies using a policy language like, say, Rego with Open Policy Agent, Gatekeeper being a specific build of OPA. If a valid scan and the current valid state of the proposed deployment artifacts cannot be verified, the deployment doesn't succeed. This lends itself easily to the interrogation of broader CVE systems like, say, maybe Twistlock or Chekhov or something else, which you may also already be running to address the situation of container running where vulnerabilities are found after the deployment. The point is the policy is not specific to any one scanning tool. The policy is effectively we don't accept critical vulnerabilities into our deployment pathway, and we provide an API that allows teams to adopt these scanning tools and prove to that API that they have successfully used them and mitigated those risks. As another example, the ownership of the compliance requirement could be a security team, meaning security team might own the policy. This team can provide the developer resources and manage the change assessment gates, or they could use like an internal proxy, like an engineering platform team. And mission controllers are a boundary function that verify certain criteria are met when our workload attempts to be deployed to a Kubernetes environment. By moving the verification of CVE reports to the boundary of a cluster, we have moved CVE compliance to the most important point of change, the environment itself. In so doing, we can safely allow the development team to completely own their pipeline leading up to that boundary. They must meet the requirements of the boundary policy in order to cross it, and they know that, and they can optimize their own processes in order to do so. Um, as another example, maybe bill of materials, and this is very similar to the CVE process we were talking about. There's some decision to make about the level of maybe SBOM interrogation. Most frequently, bill of materials relates to the artifacts you maybe publish, sell, or share. Or it may be just as simple as, are you providing an SBOM in your deployment? Yes or no, or did you create one? Then maybe that's a pass fail. There are different levels of depth you can go with those. And we already talked a little bit about sort of the approvals concept. But if you can think about it from, say, like Jira as a really specific example, let's say our policy controller has no limit on the APIs it can talk to, assuming it has internet out or egress, any verification processes that were previously controlled within CI can theoretically be moved to the deployment boundary. So like we have that product owner that needs to manage approvals for going to production. You can have your Kubernetes and mission controller literally go talk to the Jira API and verify that the feature was complete and marked off as yes by the product owner. We don't recommend manual gating in deployments, but you can define PO approval as some combination maybe of criteria. Like say, instead of an actual checkoff, it could be some form of attributes that are passing, meaning the story had previously been groomed and signed off by a product owner in much earlier phases. The work has been completed by developers, and they're passing all of their, say, maybe criteria for that feature to work correctly, and those tests are all passing. That could be considered PO sign off. To kind of recap what we've talked about so far and like reiterate on the point we're trying to make. Um, Now that we've kind of gone through that technical deep dive, the thing to really remember is you want to, the goal of what we're trying to do here is separating the work of compliance from the evidence of compliance. Um, so to kind of get into more of a technical example to follow our trend here, you might separate the validation of infrastructure config from the making of the configuration itself. Um, we want to shift like the doing of that compliant infrastructure work left as close as possible to the platform engineering team, but create enforcement at the point where that change actually occurs. In so doing, we can then meet the needs of all of our different security teams, compliance teams, and audit teams, while also giving our platform engineers the freedom to optimize their own pipelines. There's some other things to consider when we talk about compliance at the point of change. We talked a little bit about like SBOMs and provenance and that kind of thing. But there's this new concept in DevSecOps called code provenance, which effectively is proving code ownership or attestation of the origin of code. I think SolarWinds is a good example of why this is important. So this can be a pattern that's built into compliance at the point of change quite easily. Another thing to consider is open source policy agents like Open Policy Agent Gatekeeper, These are extremely useful in creating these compliant checks for our deployments, like we were talking about. We use this quite extensively to enable this pattern at different customers and users. So as an example, you might write a policy implementation for Kubernetes that uses, say, required labels or something like that for a deployment to Kubernetes. So in this example, we're saying we're requiring a certain set of Kubernetes labels, and if they're missing, we're going to deny that deployment. So this is a super simple example, but just to get you an idea. Another one we might consider is like, let's say in our engineering platform, we have certain features enabled through a Kubernetes operator. Like you can get down to this level with this pattern. Well, maybe we have, say, like a MySQL operator that lets development teams get deployments of MySQLs for themselves through like a CRD talking to an operator. Well, we might have a compliance at the point of change check that says they must use the serverless version of MySQL. And we do this because the engineering platform team doesn't want to manage non-serverless versions of MySQL platform because it creates too much friction and toil. Just as another deeper example.
Hello, got questions about anything we covered? Drop them in the comments. We would love to help. Whether it's something that we covered today or in the previous videos, like configuring observability dashboards or a deeper concept like adopting platform engineering in legacy-heavy organizations, we are happy to go back and explain or even do a follow-up. Your feedback also helps us shape the future content, so let's keep that conversation going.
Further reading, we encourage you to go to Martin Fowler's website and read the DevOps compliance article where this concept originated amongst ourselves and others at ThoughtWorks. And we definitely encourage you to check out our book, Effective Platform Engineering by Manning. It is fully released and going to print fairly soon. And yeah, for more information, just go to effectiveplatformengineering.com and check out our book. Thank you so much.
Hey, thanks for watching all our videos. What's coming up next is more exciting. You can put your platform engineering knowledge into practice by doing a few code-based exercises, as well as learning more about Gen AI in platform engineering. Stay tuned for this exciting session coming your way soon. Thank you.